Welcome to my personal guide to AWS Database, a quick review for your Cloud Practitioner exam. I put this out there to help everyone who's studying for it, and obviously a disclaimer that I'm not part of Amazon, so please forgive me if I didn't include everything for the exam. And of course, I'd like to thank SlidesGo at the bottom right for this awesome presentation. Let's begin. So number one, we like to look at or think about relational versus NoSQL databases. We have a couple apps on the left and on the right, and some things that are italicized, meaning that they might not necessarily be on the exam, but we want to be over-prepared than under-prepared. So when we begin, instead of using our EC2 drives, we want some structured data to run queries, or even just store the data. So on the left, you have two tables where if you had a column that shared the same values, you could find additional values relating to who the owner is. And for the NoSQL database, I like to think about a JSON structure. For relational databases, we begin off with RDS, which is our relational database service. And OLTP, it's pretty important, is an online transaction processing term. Basically, that's what RDS is. What is that? Basically, if you use an ATM or use credit cards, you're making transactions and you're processing them. It is a managed service, which is much different than just a regular EC2, allowing you to provision, patch, backup, and recover. You can find more on the AWS website. Now, it has something called read replicas, which allow you to increase the performance, and it has multi-AZs for disaster recovery. Now, what is a read replica? Read replicas allow you to scale based on the workload, and in general terms, your apps just communicate to that replica or get that read that data, but it can't write to that replica. It has to, or only is able to, write to the main RDS. Now, you can also have multi-AZ, which improves your high availability, and only disaster recovery in that AZ. Now, you have something called a failover database, which allows that replication to occur across multiple availability zones. And you have multi-region for disaster recovery in, regions. Now, you have Amazon Elasticache. I like to think of the similarities between EC2, where you have drives on your EC2. Elasticache is kind of in that way around the same ballpark. So you have Redis and Memcache. Basically, they're in-memory data stores, or we'll just call them caches, that allow you to have higher performance, lower latency, or faster read and writes. Basically, if I'm going to be reading that database, I want a place to temporarily store that instead of reading directly from that read replica or that database. Now we have some more stuff or some more applications. Aurora, which is just a cloud optimized, more expensive version of RDS, which supports MySQL and Postgres. We also have Redshift, which is used for, instead of OLTP, OLAP, analytical processing. That's the key, analytics. Also, when it's mentioned as a data warehouse, that's a key too. It has 3 copies of your data. It uses columns instead of rows. It also has something called a massively parallel query execution, which increases your availability. And it has fault tolerance, which is across your disk, your network, and your AZ regions, like we talked about. And of course, you have Athena, your analytics for your S3. Sometimes you can use S3 as your database, right? So now we have NoSQL, and we have something called DynamoDB. Really cool name. Now, it's basically fully managed, and is highly available as well across 3 availability zones. It's serverless, and it has low latency retrieval. Basically a key value database. Now, this is the key. If you understand relational database, you can apply almost the same logic to NoSQL. Instead of Elasticache, you can use DAX or DynamoDB acceleration. Instead of multi-region, you have global tables. But the special thing about global tables is you can read and write to any region. However, there are some problems that you may occur when you write to any region as they kind of sync together, right? And then you have DocumentDB, which is kind of similar to that cloud optimized version that we talked about, but except for the NoSQL database, or specifically MongoDB's version for JSON. And then you have the last slide, and we're wrapping up real quick. Amazon EMR, or Elastic MapReduce, basically is a cluster for big data. And it's just a collection of EC2s. Whenever you mention Apache Hadoop or Spark, think of EMR. And you want to think about Amazon QuickSight, which uses machine learning for dashboards, Neptune, the last planet in the solar system, as a graph database, AWS Glue as ETL service, basically meaning extract, transform, and load. And you want to think of that like taking data from a bucket or a relational database, doing some magic, and putting it into something like Redshift. And last but not least, you have Database Migration Service, or DMS, which takes your EC2 or utilizes it to grab data, transfer, while allowing that database to still be available. Really powerful. I hope you enjoyed that quick and short study guide. Good luck on your exam, and take care.